Okay, so we're just working on these equations. Some examples that are a little bit different is good for us to go over. This first example, I think you guys might notice it's a little different because we've got this divided by 2 over here. So we don't really want to deal with that fraction right there. So one thing we can do is get rid of the divided by 2 by multiplying both sides by 2. So we have 2 times the cube root of x is equal to the cube root of x squared. Alright, so our second step is to isolate our variable. Well, this variable, or isolate the radical, excuse me, this radical has a 2 in front, but if I divide by 2, I'm going to get back to this fraction. But this radical over here is now isolated. There's nothing outside of it, so we'll just focus on that. We're going to go ahead and cube both sides because it's a cube root. So we're going to cube both sides over here. Now on the right, the cube cancels the cube root, leaving us with just x squared. On the left, we do have 2 things to cube. We have the 2 and we have the cube root of x. So we have to cube the 2, which gives us 8. And then we cube the cube root of x, it just leaves us with x. Alright, so now we have an equation with an 8x and an x squared. We want those on the same side of the equation because they're not like terms. There's an x squared. We're going to end up factoring this. So we're going to subtract 8x from both sides. So 0 equals x squared minus 8x. This is just 2 terms, so let's, think GCF factoring. You can take an x out of both, leaves you with an x minus 8. Now that it's factored, you can set each factor equal to 0. So x equals 0, x minus 8 equals 0. And then we get 0 for one answer, add 8 to both sides, and you get a positive 8 for the other. So we got x equals 0 and 8, but now we need to see if x really does equal 0 and 8. So we go back to our original equation. I'll go ahead and rewrite it. We had the cube root of x equals the cube root of x squared divided by 2. And we're going to plug in first the 0. Cube root of 0, we want to know, does that equal the cube root of 0 squared divided by 2? Well, on the left side, the cube root of 0 is just 0. On the right, first we would do 0 squared, which is 0. And then the cube root of 0 is 0 divided by 2. And 0 divided by 2 is, 0. So that one worked out. X equals 0 is an answer. Now we have to check the other one. Plug in an 8. So we have the cube root of 8 equals the cube root of 8 squared over 2. All right, simplify the left side. The cube root of 8 is 2. On the right side, we have to square the 8 first. 8 squared is 64. And the cube root of 64 is 4. I'm going to carry down the divided by 2. 4 divided by 2 is 2, and that worked out also. So our 2 answers, 0 and 8, are both solutions. All right, next example. We have to isolate our variable, get this alone, which means subtract 4 from both sides. We have the square root of, I'm going to change this to an x if you don't mind, x minus 2 is equal to x minus 4. Now we're ready, it's a square root, so we're ready to square both sides. And see how I'm putting parentheses around both of these terms to square like that? That's very important. So on the left side, if you square that square root, it leaves you with x minus 2. On the right side, x minus 4 squared, because of this minus sign, I can't just square both numbers. I have to actually write it twice and FOIL it out. So if you FOIL that, you get x squared minus 4x plus 16. Combine like terms, we get x squared minus 8x plus 16. All right, so we have another equation with x squared and x, so that means that we are going to get everything on one side so that we can look at factoring. So I'm going to subtract this x. I'm also going to add this 2. I'm just kind of doing that all at the same time. So I have 0 equals, because these x's cancel, those negative 2's cancel, x squared minus a 9x plus 18. All right, so we have to factor a trinomial, factors of 18 that add up to negative 9, and we come up with a negative 6 and a negative 3. Negative 6 times negative 3 multiplies to 18. Negative 6 plus negative 3 adds up to a negative 9. So we have 0 equals x minus 6 times x minus 3. Set each one equal to 0 to solve. And we get x equals 6 and 3. So does x really equal a 6 and a 3? That is the question that we have to check. So we go back to our original equation, which is the square root of x minus 2. We had that plus 4 on the outside equals x. So first one we check is the 6. Square root of 6 minus 2 plus 4. We want to know, does that equal 6? Well, 6 minus 2 is 4. Square root of 4 is 2 plus 4 is 6 equals 6. All right, so that one worked out. Now we're going to check the 3. We have square root of 3 minus 2 plus 4. Does that equal 3? All right, well, 3 minus 2 is 1. Square root of 1 is 1 plus 4. 1 plus 4 is 5, which does not equal 3. So here's an example where squaring both sides gave us that extraneous solution. So 3 does not work, so our only answer is x equals 6.